Hello and welcome to this first video in a series on bonding. What we're going to be talking about in this video is we're going to be talking about ionic bonding. But before we begin, let's have a little recap of some of the important information that you need to remember. So, on to the recap. A couple of things that we've looked at in previous videos is we've talked about atomic structure. So what we've talked about is we've talked about the structure of the atom, and within the atom we have subatomic particles and those three subatomic particles that you need to know about are neutrons, protons and electrons. And what we did is we talked about the different masses of those subatomic particles. So neutrons and protons had a mass of 1, electrons negligible mass, and we talked about the charges on those different subatomic particles, neutrons being neutral, protons having a +1 charge, and electrons having a -1 charge. We also talked about how we could draw electronic configuration. Okay, so we talked about electronic configuration. And what we did is we talked about the fact that electrons are arranged in shells around the nucleus of an atom, and we talked about how we could draw that. And we talked about how many could go in each shell. So for instance, if I was to draw some of the noble gases, the first noble gas here, okay, we have is helium, which has an electronic configuration of 2, and then moving on to the next one, 2 in our first shell, and then in our second shell we have 8. Like so. So this is neon, and neon has the electronic configuration 2, 8, and then if I was to move on to the next one, you're already probably saying how many electrons are going to be in this next shell. You'd be correct in saying it's 8. So here we go, here's my third shell. 1, 2, 3, 4, 5, 6, 7, 8. And this is argon. 2, 8, 8. And at the time, I called these diagrams for drawing electronic configuration dot and cross diagrams. However, there are no dots. Now this is where the dots come in. So why don't we move on to that? Let's talk about how these dot and cross diagrams fit in. We're going to talk about how ions form. We're going to talk about how we can work out the charge on an ion, and we're going to talk about what an ionic bond is. So let's get started. So if anything that I talked about in the beginning of this video didn't make too much sense to you, then I'd suggest to go watch some of my previous videos on atomic structure and electronic configuration, and then start talking about bonding. You need to make sure you've got a solid grasp of that stuff before you start talking about this. So first off, let's talk about a bond. Okay, what is a bond? A bond is essentially a force of attraction that holds things together. Okay, the things in this case are atoms. Okay, that is what a bond is. Okay, it's a force of attraction that holds bonds together. Now, there are many different types of bond. Okay, 3 that we're going to sort of focus on in this series of videos. One is called covalent. Another we're going to talk about is called metallic. And the last that we're going to spend some time talking about in this video is ionic. Now, we're going to be focusing on ionic bonding, which involves ions. So first off, what is an ion? So in the beginning of this video, I drew out the electronic configuration of the noble gases, helium, neon, and argon. They have the electronic configuration of 2, 28, and 288. Now, what do they have all in common? It's the fact that they have a full outer shell of electrons. Now, when an atom has a full outer shell of electrons, it is more stable. Now, the problem with this is that most atoms do not have a full outer shell of electrons. Now, if I was to draw out lithium, for example, lithium here has 3 electrons, 2 in its inner shell, and then 1 on its outer shell. So it has the electronic configuration 2, 1. Now, how could this lithium atom get a full outer shell of electrons? How about you pause the video, have a think, see if you're right. Well, what did you say? There's 2 ways in which this lithium atom could get a full outer shell of electrons. It could gain 7 electrons, and I'm just going to write electrons as E-. The other way that it could get a full outer shell of electrons is to lose 1 electron. Now, which of those 2 do you think is easier? To gain 7 or lose just 1? It's losing that 1. So what does our lithium atom now look like? Well, it looks like this. We have our lithium, and it looks a little like this. However, this is now no longer what we call an atom. Okay? This is a charged particle. And we call this an ion. So this here, in this left-hand one, this is a lithium atom. And over here, this is a lithium ion. Now, what's the big difference here? Well, the big difference here is this has lost 1 electron. So, if we were to think about the balance of subatomic particles now, okay, we would have 3 protons and only 2 electrons. In the atom, we've got 3 protons and 3 electrons because all atoms are neutral. This, however, has a charge. It's got 3 protons and 2 electrons. So let's think back to the last video. Okay, we talked about that a proton has a charge of +1, a relative charge of +1. We talked that electrons had a relative charge of -1. So if we've got 3 protons, that's +3. If we've got 2 electrons, that's -2. So 3 minus 2 is +1. So this has a charge of +1. Okay, well, how do we illustrate that? Well, when we write the element, okay, over here, if I was to write lithium as an element, I would just write Li. Okay, that would be my element. Over here, if I was to write the lithium ion, I write Li+. So this is the atom, Li, this is the ion, Li+. Okay, so how is this important? Well, if we have charged particles, and let's say, so how is this important? Well, the big question is, where did the electron go? Well, what has to happen if an atom loses an electron? That electron's got to go somewhere. Now, in this case, we're talking about bonding. We're talking about the attraction between 2 atoms. So, this is an ionic bond that we're going to be talking about. Well, here's the bit of information that's important. There's a second ion involved. So what could that second ion be? So let's look at the other end of the periodic table. Let's think about fluorine. Now, here is where the dots come in. I'm going to draw these as dots. Fluorine has the electronic configuration 2, 7. There's my fluorine. Okay, it has the electronic configuration 2, 7. So if I was to ask the same question, how could this get a full outer shell of electrons? Well, it would be the opposite to this. It could lose 7 electrons, or it could gain just 1. Now, which do you think is the easiest one? Yeah, well, I hope you were sort of thinking, well, probably if it's to lose 1 electron, it's to gain 1 electron. So where does that electron come from? Well, it comes from this lithium. And how do we show that? Well, here we go. Here's my fluorine. Ooh. So how do we show that? Well, here's my fluorine. Here's the first 2 electrons. There's 1, 2, 3, 4, 5, 6, 7. And then what we do is we use the cross from our lithium. So what we've now got here, something with the electronic configuration 2, 8. Okay, so here we've got a fluorine atom. And then over here we've got a fluoride. Oops. Ion. Now notice that the name here has changed a little bit. Fluoride ion. And you'll see more examples of that in future videos. But again, if we were to think about the number of electrons, what's happened here, okay, with our fluoride ion, we've got, in fluoride, we have 7 protons, and now we have 8 electrons. So this fluoride ion has a charge of -1. So how do we write that? Well, we write F minus, like so. We've shown how an atom can turn into an ion. Now these 2 ions are different. We've got one that's positive and one that's negative. Let's talk about a couple of other key terms here. We call a positive ion, okay, we call it a cation. We call a negative ion an anion. How on earth do you remember this? Well, easy way of remembering it is cations are positive. There we go. That is how you can remember that. Okay, cations are positive. Okay, let's write that in, because I like that. It's silly, but it works. Okay, so how do we illustrate this together? And how do we illustrate a ionic bond? Okay, well, what we do is we draw out the atoms using... So what we do is we draw out the ions using a dot and cross diagram. We put them next to each other. So here's our lithium, and I'm going to use crosses. Here's our fluorine, and I'm going to use dots. Now remember that our fluorine ion has gained 1 electron from our lithium. Now what else do we do? Well, the other things we need to do is we need to make sure we write the element within the middle. It's always good to write that first. Okay, so we've got Li and F. Now to finish off this diagram, what we do is we draw a bracket around each of the ions here. And what that enables us to do is write the charge of the ion in the top right-hand corner. So if somebody was marking this, what they would do is there's 3 things that they would mark. The first is that have you got the number of electrons correct? The second thing they looked for is the brackets. And last but by no means least, they would look to see if you've got the charge correct. So they would count up those electrons, making sure you've got the correct number, the correct electronic configuration around those ions. Have you got the brackets, and have you got the charge written correctly? Okay, so there's quite a lot of information here. Let's summarize it doing one more example, and then you can have a go. Right, here's another example. Let's have calcium and oxygen. So let's summarize them in atom form. So let's first off think about them as an atom. So what we have is we have calcium. Now personally, I tend to draw the one that's got more electrons with crosses. It's just what I try and do. So calcium has the electronic configuration 2882. Picked one with lots of drawing to do. Here we go. Now, getting around there. One more. And here's our oxygen, which has only got 6. Thank goodness. So let's have a quick think about this one. There's going to be a transfer of electrons because we are going to have our electrons move from one side to the other. So our calcium, here it's slightly different though. We've got 2 electrons in the outer shell, so it needs to lose 2. Oxygen, luckily though, needs to gain 2. So what we can do there, just draw some arrows to illustrate those electrons moving across. So then when we come to drawing our ions, so these are the atoms. When we then come to draw our ions, what we can do is just put them down to here. Here's our calcium. Two, 3, 4, 5, 6, 7, 8. And then one more around the outside with its 8 electrons. And then we've got our oxygen. Okay, and now we've got to draw those brackets around the outside. And we've got to do the charge. So the charge on the calcium ion, it's lost 2 electrons, so that's going to be 2 plus. And our oxygen has gained 2 electrons, so it's going to be 2 minus. Okay, and this is going to be our calcium oxide, because the oxygen is going to become an oxide ion. Oxide ion, and this is our calcium ion. Okay, and our positive ion here, this is our cation, and this over here is our anion. Okay, so last but by no means least, how do we define this ionic bond? The definition of an ionic bond is an ionic bond is a strong force of electrostatic attraction between oppositely charged ions. So question, what is an ionic bond? Answer, An ionic bond is a strong force of electrostatic attraction between oppositely charged ions. So just to finish off this video, I know it's a long one, well done for sticking through it. The last thing we're going to talk about is simply an example for you to have a go at drawing an ionic bond. Right, here we go. Here's some questions for you. So draw using a dot and cross diagram the bonding in sodium chloride, NaCl. Here's a hint, it's an ionic bond. What is a cation? What is an anion? And what is the definition of an ionic bond? I've also written how many marks these kind of questions would be. So give the video a pause, grab yourself a scrap bit of paper, have a go at them, and see how well you do. Okay, so I'm going to go through these answers, starting with the first one. Using a dot and cross diagram, show the bonding in sodium chloride. I'm going to draw this out and speed it up for you. Let's go. And last but by no means least, a minus on our chlorine there. So first part of this question here, okay, what we're looking for, those 3 marks. Have you got the number of electrons correct? Have you got those brackets? And have you got those charges correct? Positive on the sodium and negative on the chlorine. Have you used dots and have you used crosses? Question number 2, what is a cation? Well, a cation is a positive ion. What is an anion? Well, an anion is a negative ion. And what this video was all about, ionic bonds. What is the definition of an ionic bond? An ionic bond is a strong force of electrostatic attraction between oppositely charged ions. We are done. Okay, that is a big old lesson today, longer than any other episode I've done so far at the time of me making this video. Well done on sticking with it. What we're going to talk about next time round is we're going to talk a little bit about naming ionic substances, a little bit more about what we call ionic lattices, and also addressing the problem of, well, what happens if we have 2 ions that don't match up in charge? What happens if I have a cation that has a +2 charge and an anion that only has a 1- charge? We'll talk about that next time round. So thank you very much for tuning in to this episode. Please give the video a like, subscribe to the channel if you haven't already, if you want to stay up to date with some of these GCSE tutoring videos. So, as always, thank you very much for watching, and I will catch you in the next video.